The Theory of Political Economy by William Stanley Jevons. Chapter 1 Introduction Part 1 Mathematical Character of the Science. It is clear that economics, if it is to be a science at all, must be a mathematical science. There exists too much prejudice against attempts to introduce the methods and language of mathematics into any branch of the moral sciences. Many persons seem to think that the physical sciences form the proper sphere of mathematical method, and that the moral sciences demand some other method, I know not what. The theory of economics, however, is purely mathematical in character. Nay, believing that the quantities with which we deal must be subject to continuous variation, I do not hesitate to use the appropriate branch of mathematical science, involving, though it does, the fearless consideration of indefinitely small quantities. The theory consists in applying the differential calculus to the familiar notions of wealth, utility, value, demand, supply, capital, interest, labor, and all other quantitative notions belonging to the daily operations of industry. As the complete theory of almost every other science involves the use of that calculus, so we cannot have the true theory of economics without its aid. To me it seems that our science must be mathematical, simply because it deals with quantities. Wherever the things treated are capable of being greater or less, there the laws and relations must be mathematical in nature. The ordinary laws of supply and demand treat entirely of quantities of commodity demanded or supplied, and express the manner in which the quantities vary in connection with the price. In consequence of this fact the laws are mathematical. Economists cannot alter their nature by denying them the name. They might as well try to alter red light by calling it blue. Whether the mathematical laws of economics are stated in words, or in the usual symbols x, y, z, p, q, etc., is an accident, or a matter of mere convenience. If we had no regard to trouble and prolixity, the most complicated mathematical problems might be stated in ordinary language, and their solution might be traced out by words. In fact, some distinguished mathematicians have shown a liking for getting rid of their symbols, and expressing their arguments and results in language as nearly as possible approximating to that in common use. In his Système du Monde, Laplace attempted to describe the truths of physical astronomy in common language, and Thomson and Tate interweave their great treatise on natural philosophy with an interpretation in ordinary words, supposed to be within the comprehension of general readers. These attempts, however distinguished and ingenious, their authors soon disclose the inherent defects of the grammar and dictionary for expressing complicated relations. The symbols of mathematical books are not different in nature from language. They form a perfected system of language, adapted to the notions and relations which we need to express. They do not constitute the mode of reasoning they embody. They merely facilitate its exhibition and comprehension. If then economics we have to deal with quantities and complicated relations of quantities, we must reason mathematically. We do not render the science less mathematical by avoiding the symbols of algebra. We merely refuse to employ, in a very imperfect science, much needing every kind of assistance, that apparatus of appropriate science which is found indispensable in other sciences.